Subscribe to the channel to discover the technologies that transformed modern flight. Today, we'll explore in detail the fascinating workings of a head-up display, the system that allows pilots to see vital flight data without ever taking their eyes off the horizon. Inside the cockpit of a fighter jet or a modern commercial aircraft, there's a subtle but essential element, the HUD or head-up display. This device projects critical flight information directly into the pilot's line of sight, overlaying data onto the real-world view ahead. Its primary purpose is simple yet revolutionary: to keep the pilot's eyes focused on what matters most, flying. The concept of the HUD was born in the 1950s and 1960s, when British military engineers realized that fighter pilots were losing precious seconds shifting their gaze between the instrument panel and their targets. The idea was to project key information onto the windscreen, allowing the pilot to maintain both situational awareness and instant access to flight data. That idea became the foundation of one of the most important aviation technologies of the modern era. The HUD's operation is a blend of optics, electronics, and mathematical precision. The system consists of three main components: the flight data computer, the optical combiner, the transparent glass in front of the pilot, and the projector. The computer gathers information from the aircraft, such as speed, altitude, attitude, heading, climb rate, and trajectory, and sends it to the projector. The projector then creates a virtual image that is reflected onto the combiner, positioning it so that it appears to float over the real horizon. The optical magic happens through a principle known as collimation. Unlike an ordinary image, the HUD projects light in parallel beams, so the human eye perceives the data as if it were at an infinite distance. This means the pilot doesn't need to constantly refocus between the screen and the outside world. In other words, while observing the sky, terrain, or runway, the pilot also sees symbols, numbers, and indicators seemingly suspended in the air, perfectly aligned with reality. Among the most common information displayed on the HUD are airspeed, altitude, heading, pitch angle, artificial horizon, targeting reticle, climb or descent rate, and landing cues. In fighter jets, the HUD also shows weapon status, target distance, and aiming symbology, allowing attacks without looking down at lower panels. In commercial aircraft, it assists during approaches and landings in low visibility, projecting runway outlines and guidance even before the pilot can see the ground. The HUD is designed to operate in all lighting conditions. During daylight, its brightness adjusts automatically to remain visible even under direct sunlight. At night, it dims to avoid glare. The combiner glass is specially coated to reflect only the light spectrum used by the projector, ensuring the symbols appear bright and crisp without obstructing the real view outside. The technology is so precise that every reflection, line, and symbol is calibrated to appear at the exact point in the pilot's vision. In modern fighters, such as the F-35 Lightning II and the Eurofighter Typhoon, the HUD has evolved into even more advanced systems. In these aircraft, the projection has been integrated directly into the pilot helmet, creating what is known as a helmet-mounted display, HMD. In this system, the helmet visor functions as a mobile HUD that moves with the pilot's head. Wherever the pilot looks, the data appears. It's a total fusion between human vision and machine intelligence at supersonic speed. In commercial airliners like the Boeing 787 Dreamliner and Airbus A350, the HUD has become an essential safety tool. During foggy conditions or automatic assisted landings, the pilot sees a synthetic view of the runway, reference lines, and directional cues, enabling precise landings even in minimal visibility. In critical moments, the HUD can make the difference between a safe touchdown and a dangerous approach. The future of the HUD promises even deeper integration between the real and digital worlds. The newest generations are being developed with augmented reality, AR, capabilities, projecting three-dimensional imagery that dynamically adjusts to the pilot's head position. This means that soon information will appear to float in true spatial depth, highlighting runways, paths, and even nearby aircraft. Imagine seeing a virtual runway emerge through thick clouds. That's the HUD transforming data into pure vision. Another advancement involves integration with synthetic vision systems, SVS, and enhanced vision systems, EVS, which use infrared cameras and radar to display terrain even in total darkness. These images are merged into the HUD, allowing the pilot to see what the naked eye cannot. The fusion of sensors and projection turns flight into an expanded sensory experience, where every data point becomes an image, and every image a decision. Yet despite its sophistication, the HUD's fundamental purpose remains unchanged since its creation: to simplify the pilot's life. It reduces cognitive workload, improves reaction time, and enhances situational awareness. It's the difference between flying the airplane and being one with the airplane. The pilot no longer alternates between looking inside and outside. They simply look forward, with everything they need in view. Ultimately, the head-up display is more than an instrument. It's the bridge between human perception and machine precision. It transforms data into vision, information into instinct, and makes flying almost intuitive. Each flight, whether a fighter jet slicing the sky at Mach 2 or a commercial jet landing through fog, carries a touch of technological magic. The power to see the unseen and fly with eyes on the future.